This is lesson 4.1, solving systems of equations by graphing. To start off, let's start with a line of best fit problem. Go ahead and pause your video and see if you can find the line of best fit for the given data and answer the questions. All right, to find the line of best fit, you're going to open up your Desmos calculator and enter the table. So I've already done that. Just as a reminder, if you go into the Desmos calculator and hit the plus button, you can add a table right there. Now, you may not be able to see your points at first. I can see them because I adjusted my window. So if you go to the wrench, I changed my X values from 0 to 10 and my Y values from 45 to 75, given the data that I have. So now we need to find the line of best fit. So if I'm going to click on the next line, we're going to type in Y1 and then the squiggly, and then MX1 plus B. And you can tell it gives us our data. You change that to a lowercase y. There you go. It gives us our R value, which is our correlation coefficient, and it gives us our slope and our y-intercept, which is the information we need to solve the warm-up problem. So I'm going to write it in function notation, but you could write it as y equals mx plus b. But because I'm writing in function notation, I'm going to start off by writing it as f of x. All right, my slope is negative 1.8. I'm rounding to the nearest tenth. And my y-intercept is 69.3. Okay, what is the correlation coefficient? So if we're looking at our R value on the calculator, the R value is negative 0.8106. Now, what does that tell us? It tells us a couple things. One, it tells us that it's negative because of this negative here. And I can also tell when I look at my graph that my slope of my line of best fit is negative. Okay, now the number and the closeness to the line tells me whether it's going to be strong or weak. A really strong line of best fit, these dots would be almost exactly on the line. Okay, would form almost a straight line. A very weak line of best fit would have dots that are kind of spread out a little bit, but they kind of fall along that trend. Okay, no correlation would mean that there are dots spread all over the place. You can't tell whether it's increasing or decreasing. Now, if we look at the numbers, this number is negative 0.8, is kind of close to 1, but not super strong, but it's not weak either because weak would be 0. So I'm going to say it's a somewhat strong negative correlation. Okay, it's kind of in between. It's not the strongest, not the weakest, but kind of in between there. Okay, it says using the regression equation, which is what we found, our line of best fit is the same thing as linear regression. What would be the predicted speed if there were 8 patrol cars on the highway? So what we're going to do is we're going to take our original equation and we're going to substitute 8 in for x because x represents the patrol cars. So really, I'm trying to find f of 8. So I have negative 1.8 was my slope. I'm substituting 8 in for x. All right, remember this side is just the name. So we're going to keep that. And if I type all of this in my calculator, I should be able to get my answer. Now, if you don't have the scientific calculator, you can get it on our on a Schoology, or you could use this graphing calculator to help you as well. So let me go ahead and minimize so we can see the equation we're putting in. All right, so I can type it in right here, negative 1.8, parentheses, we're substituting 8 in for x, plus 69.3. All right, and I get my answer right here of 54.9. All right, we could probably say approximately 55 miles per hour because it's saying what would the speed be. So that falls right in line. The actual speed was 52, so 55 is just a little bit off. Remember, the line of best fit is not exactly going through all of our points. It's a prediction. It is used to tell the trend So as long as our information is kind of close to what we were talking about, then that's good. All right, talking about our lesson for today, solving systems by graphing. Okay, this is a review activity. You guys did learn it in 7th grade, so this should be a good refresher for you. And we're going to talk about other ways of solving systems as well next week. So there are guided notes in the Schoology folder if you would like to open those up and follow along as we go. You can pause your video from time to time to fill in your notes. So here are 2 vocabulary words we have to know what they mean before we can begin. The first one is a system of linear equations. So a system of linear equations is 2 or more linear equations. So we're talking about more than just one. Okay? And the solution to those would be where the 2 lines intersect, or 3 lines, or whatever the case may be. We're going to start with 2. Okay? Now these are the possibilities we can have. You could have 2 lines. You see my red and my blue line. They cross one time, so they have one solution. And that is an example of just 2 intersecting lines. Okay, intersecting lines cannot hit more than once. Okay, here is an example of what the equations would look like. So if you notice, the slopes are different. And in this case, the y-intercepts are different. They could be the same, but the slopes definitely have to be different for intersecting lines. Okay. In example 2, you see these 2 lines never touch. They are examples of parallel lines. Parallel lines have 0 solutions because they do not intersect. So here is an example of equations for this. And if you notice, our slopes are the same, but our y-intercepts are different. Okay, and this is the same when we talked about parallel and perpendicular lines a few lessons ago. The slopes will always be the same if the lines are parallel. And that's how you know they'll never touch. Now this one here is a little hard to see. I moved them to the side a little bit just so you could see that they are exactly the same. They are the same line. It's one line right on top of the other. So that blue line is right on top of the red line. This is an example of infinitely many solutions. Every single dot along this line was considered a solution. So here's what the equations could look like. Now I know right off the bat it doesn't look like they are the same, but if you were to take the second one and solve for y and put it into slope-intercept form, you will see that you would get 2x plus 1, which is exactly the same as the first one. All right, how do we graph systems of equations? Well, we have to graph them one at a time. So the first thing you want to look for is, are they in slope-intercept form? So both of these examples are in slope-intercept form. So I'm going to go ahead and start with my first one. I'm going to graph it in red, and I'll do the second one in blue so we can kind of see the difference between the 2 of these. So remember, when you're graphing in slope-intercept form, you always start with your b, or your y-intercept. So my y-intercept is -3. So I'm going to go down to -3 on my y-axis and put my dot. Now my slope is 2, or I can write 2 over 1. So that tells me I need to rise 2 and run 1. You're always running to the right. I always think run and right both start with the same letter. Now I can do that as many times as I want. Rise 2, run 1. Rise 2, run 1. Now I have a couple points. I tried to do at least 3. Now I can go ahead and I can connect these dots. And you want to try to connect them all the way across your grid the best you can. It's a little hard on the computer, so sometimes you have to readjust just a little bit to make them work out. All right, now we're ready to graph our second line. Okay, my second line, my y-intercept, or my b, is -1. And my slope is 3/2. So that tells me I need to rise 3 and run 2. Rise 3, run 2. Okay, and it looks like my graph, my first one was off just a little bit because it should have gone right through that point. All right, let's go ahead and connect these dots, even though I already know where they're going to intersect. Okay, I know that they're going to intersect through that point that I just drew. Okay, and then I have to label my intersection as an ordered pair. So if you're looking at this ordered pair is where they intersect, and that is the ordered pair for 5. Okay, so anytime they ask you what is the solution to the systems of equations, you need to write it as an ordered pair Or you can say there are no solutions or infinitely many solutions. All right, let's look at this first one. So the top one is in slope-intercept form. So let's go ahead and graph that how it is. All right, let me delete that little extra line there. All right, that one wants to stay, that's fine. All right, let's go ahead and graph the first line. So my intercept is 4, 1, 2, 3, 4. Let's try that again. My intercept is 4, and my slope is -2. So -2 tells me to rise down -2 and then run 1 to the right. So down 2, 1 to the right, down 2, 1 to the right. I'm going to keep on doing that over and over again. All right. And just enough so I have enough to form my line. And I'm just going to extend it out just a little bit because I'm not sure exactly where it's going to hit. All right, my second line, if you're looking at this, this is not in slope-intercept form. So I have to solve for y. I want to get y by itself. So I want to say y equals. So what I have to do is I have to add 1 to both sides. So that way these cancel out and I end up with y equals x plus 1. Because these ones right here cancel out. So now it's in slope-intercept form. Now I can go ahead to 1 and put my dot. And I can rise 1 and run 1. Because there's no coefficient, so it means I'm going to rise 1 and I'm going to run 1. Rise 1, run 1. We keep on doing that over and over again. All right, let's go ahead and graph our line. All right, and we can see that they're going to intersect right here, and that ordered pair is 1, 2. Whoops, helps if I write it correctly. Let's try that again. 1, 2, not 2, 1. 1, 2. All right, let's take a look at this one on the right. They are both in slope-intercept form. That makes me happy because then I have less work I have to do. So I'm going to start at 2 for my first line. And I'm going to rise 1, run 2 according to my slope. So rise 1, run 2. I'm going to rise 1, run 2. And I should have enough to go ahead and graph that line. Now my red line, okay, this one I'm going to start at +1. That should be red. Let's go ahead and try that again with red so we can tell the difference between our two lines. This one I'm going to rise 3 and run 4. So I'm going to go up 1, 2, 3 and run 1, 2, 3, 4. And I can tell I'm going to hit right here, which is the same place that the other one hit. Okay, and these would keep on going. But that ordered pair looks like 1, 2, 3, 4, 1, 2, 3, 4. So it looks like this ordered pair would be 4, 4. All right, so there are a few more on your worksheet. Go ahead and graph these lines and come back and check your answers. All right, for number 3, for the first one, first of all, they're both in y-intercept form, so we're good to go. My first one does not have a y-intercept, so I'm going to start at 0. It's like saying +0 there. So we're going to start at the origin, and we're going to rise 1 and run 2. And I can go ahead and draw my line. And then for my second line, I'm going to start at +3. And I'm going to go up 1 and right 1. Up 1, right 1, up 1, right 1, because my slope is 1. And I'm going to go ahead and connect those dots. And I can tell they're going to intersect right here. And that ordered pair, let's see what it is. 1, 2, 3, 4, 5, 6. So -6 is my x. And my y looks like it's -3. All right, for number 4, the first one is not in slope-intercept form, so you have to fix it. You have to solve for y. So this would be y equals -2x plus 8, because you would subtract 2x from both sides. So you're going to start at 8. 1, 2, 3, actually grab red. 2, 4, 6. I'm going to start all the way at the top. And my slope is -2, so I'm going to go down 2 and right 1. All right, if it's a blue line, it's okay. We'll just do the next one in red. All right, this one we're going to start at 1, and we're going to go up 1 and right 3. And I can see right there is where they're going to intersect. All right, let's go ahead and draw the intersection right there. And that ordered pair, if we look at it, is going to be 2, 4. Okay, so they all have had one intersection so far. All right, so I'd like you to go ahead and do the same thing for these ones here and tell me the solutions for each one. So go ahead and pause your video. All right, so number 1, if we start at -1 and go down 2, right 1. My graph is going to look like that. All right, the other one, I start at -7. -7 is off of my grid. And my slope is negative, so I need to do the opposite. So instead of going down 4 and right 1, I'm going to go up 4 and left 1. So if I'm at -7 on number line, and I go up 4 spaces, so I'm going closer to 0, that takes me to -6, -5, -4, -3, and I would move over to -1. All right, so -3, -1 would be my next point. All right, let's change it to blue. And then I would go up 1, 2, 3, 4 over 1, up 1, 2, 3, 4 over 1. So these ones look like they intersect off of my grid. They would be right up here, and that looks like it might be -3, 1, 2, 3, 4, 5, -3, 5. All right, for this one here, you have to solve for y in the first one. So you have y equals, the 18x will move over and become negative. And so -18 divided by -3 is 6. And then the 21 divided by -3 gives me -7. Now looking at these, I don't even have to graph it. I could tell they are the exact same line. So this one's going to have infinitely many solutions. Okay, this one here, the first one solved for, the second one is not. So I have to move the 6 over, which would make it -6x, and then you divide it by -1. So we'd have y equals 6x, and then 1 divided by -1 is -1. Now I can tell my slopes are the same. So this one's going to have parallel lines, so it's going to have no intersection or no solution. Without even graphing it, I knew there was going to be no solutions. Okay. All right, down here, let's look at these. I'm going to see if I can do it without graphing it. You obviously probably have graphed it, but we'll double check and confirm. This one here, they're both in slope-intercept form. I can tell they have different slopes, so this one's going to have one intersection. Okay, so you should have an ordered pair for your answer for that one. Okay, this one here, again, different slopes. So this one is also going to have one intersection. Now this one here, we have to solve the second one. So I'm going to move my x over and make it negative. So -1 divided by -2, I would have y equals 1/2 x. And then -6 divided by -2 is +3. I can tell I have different slopes, so this one also would have one solution. If you want to know what those one solutions are, come see me in the virtual classroom and we can talk about what those solutions are. But just for time's sake, I am going to skip through. I just want you to know that they are all one solution on the bottom. All right, lastly, I want to talk about a word problem involving these. So we have two different caterers. We have caterer A, who charges $15 per person and $100 to set up the tables. So if I were to write an equation for caterer A, okay, it says $15 per person. That tells me multiply. So I can say y equals 15x, 15 per person, where x is my person, and tells me to add $100 is our one-time fee just to set up the tables. All right, caterer B charges $20 per person, so that's 20x, and $50 to set up the tables. So we need to graph this system of equations. So my first one, I'm going to start at 100, and I'm going to go up 15 and over 1. Now on this one, you got to figure out what they're counting by. They're counting by 1s going to the right, and it looks like they're counting by 50s going up. Okay, so you have to kind of be careful. You don't want to go up one space because that represents 50. We want to go up 15, which would be a little bit less. Okay, so you're going to have a graph that is increasing little bits. Okay, now this one, I'm just going to kind of graph what I think it would look like, something like that. All right, this one here, we have, you start at 50, and you're going to go up 20 and over 1. So again, be careful because you don't want to go up 1. You want to go over 20, which would be a little less than over 1. So this one's going to be a little hard to tell what it is. So the best way to do this is to set the two equal to each other. Okay, just because this is not the greatest graph that they gave us. So we're going to say, we're going to chop off the y's, and we're going to say 15x plus 100 equals 20x plus 50. Because we want to know what will, it says, for what number of guests will the cost of caterer A be the same as caterer B? So we want them to be equal to each other. All right, so if I solve for x, I get negative 15x I have to take away from both sides. So we have 100 equals 5x plus 50. All right, I would still want to solve for x, so I'm going to subtract 50 from both sides. So I get 50 equals 5x. So x is going to be equal to 10. So remember, x stood for per person. So the number of guests would be 10 people. And the cost at that point, if we've substituted 10 into either equation, it doesn't matter. I'm going to substitute into this one. 20 times 10 is 200 plus 50. The cost will be $250. All right, so I just wanted to show you an example of a word problem. Sometimes they'll give you a graph that you're able to actually graph, and sometimes it's just off a little bit. So if they are off and they want to know the same cost for both, set them equal to each other and solve for x. All right, there is an exit ticket. This is on Schoology. It's 4 problems just to gauge how you did with this topic. If you have any questions, I will be available in the virtual classroom.